Hey guys, I just wanted to review a couple of things, a couple of the basics here. So far, what we've talked about in our circles geometry unit is we've looked at these things called tangent lines, and you can see I drew a tangent line here from A to P, from here, basically running from here to here. So this tangent line we call line segment AP. We talked about P being a point of tangency. And the last thing we spent a little bit of time talking about is this line here, which we said was our radius. And we said when the radius actually hits the point of tangency, it creates a 90 degree. And we talked about that. We said the radius can be drawn perpendicular to the point of tangency. That's what 90 degrees basically means, is a perpendicular line. So I figured out that that can be my radius. And from there, we were able to make triangles, and we came up with a few key things with triangles. We talked about triangles, and we said, well, wait a second. Triangle rules, just to review, we said that our internal angles always add to 180 degrees. So we thought that was a triangle rule, and that works for any triangle, not just right angled triangles, not anything specific to that, any triangle. So if I had an equilateral triangle, I just want to show you guys something. If I had an equilateral triangle, and what that means is that all these side lengths are the same. Well, that means these three angles inside have to be the same as well. So I would simply say, well, I'm going to take my 180 degrees, and I could divide it between 3 because I have 3 angles that are exactly the same in an equilateral triangle. And we can figure out the angles for an equilateral triangle will be 60 degrees because 180 divided by 3 is 60. So now I know these angles here are 60 degrees. So that's kind of a rule that we have. Some other things that we might know about in terms of angle, if we're looking at triangles, is if we have an isosceles triangle, and that's where these two sides are the same, but this is different. So this is called an equilateral. This one here is called an isosceles. Uh-oh, spelling's going to be an issue. An isosceles triangle. So one of the things with an isosceles triangle is this angle is exactly the same as that angle. So these angles are the same. So in an isosceles triangle, if the side lengths are the same, those angles have to be the same as well. So we can turn around and solve this. If we know one of the angles in an isosceles triangle, we can find the others. Okay, the reason why this is important and these ideas in triangles are super important is because we've spent a ton of time talking about triangles up to this with Pythagoras' theorem, right angle triangles, solving unknown angles. And that's everything we've done so far. So what I want to do today is I want to start talking to you very briefly about a new idea, and it's called chords. And all a chord is if I'm looking at a circle, a chord is a line running across a circle. So we refer to that as a chord. So a tangent touches a chord or touches a circle at one point. A chord runs through the circle and touches it on either side. So we could say this is chord A, and I could put a thing here. This is chord AB. We still need to know the center of the circle. We still usually refer to that as an O. And now when we're looking at this, we can actually develop another rule connected to chords. We can actually run a line down here, and if that line is not perfect there, if that line happens to hit this line at 90 degrees, so if a line happens to hit the chord at 90 degrees, if a line passes through the middle, which we know is point O, and is 90 degrees at the chord, which we say perpendicular bisect, held it too long and it made a line, and it perpendicular bisects the chord. So that's basically saying we've created a 90 degree at that point. So we say it's a perpendicular bisector of chord AB. Then the sides are equal. So I'm just going to put it in red so you can see what I'm doing here. But if I have this, basically this point here, which we can call P, will divide line segment AP and line segment BP to be exactly the same length. So what ends up happening is if we produce a perpendicular bisector running through the center of my circle, it cuts the chord into equal sides. So we refer to that as a perpendicular bisector. Bisector means we're cutting it into two. So we have this idea that a chord can be cut into two by having essentially a segment of my radius passing through the chord at 90 degrees. So as long as I have that 90 degree. So that gives us two little lines of understanding. Because I can also look at a picture like this, whereas if I had a circle and I had a chord running through it, and I told you this is chord AB, and I told you that this is point O, the origin, or the middle of my circle, I could turn around and measure two things. I could draw a line down, and I could say, well, here's a line that's coming from the origin, and it strikes there. And I'm not going to tell you that it's at 90 degrees, but I am going to tell you that both of these line lengths are the same length. Knowing that, you can now infer or you can make an assumption that this has to be 90 degrees because the two line segments are the same. The chord has been bisected. So if the chord is bisected, then there is a 90 degree. So you realize these two rules that I'm kind of talking about, they work opposite to one another, right? In the first example, I knew that I had a 90 degree. I'm just going to do it in like a purple color so you guys kind of see something different. I knew that I had a 90 degree, and based on that 90 degree, I inferred that these two lines were the same length. Whereas in this scenario, I knew these two lines were the same, and I knew, therefore, that this had to be 90 degrees. So they kind of work opposite to one another. Now, the reason why this is important, these ideas, so in other words, a line passing through the middle, part of my radius, cutting my line into two equal segments, the angle is 90 degrees, or if the line is cut into two equal segments, the angle is 90 degrees, helps me solve questions when I'm getting into scenarios like this. So an example of a question that I might have where I'm looking to solve something like this, and I'll do it in black again. I could draw a circle, and I could give you a scenario where I have my chord running here, and I seem to always be doing the same one, but that's okay, AB, and I have my middle point, O, and now I'm going to tell you a couple of things. I'm going to tell you I have a line running out here, and I have a line running out here. Now, both those lines, I'm going to say are there. I'm going to say I have another line running down here. So now I have a couple of things to figure out. First off, I'm going to tell you that these two lines are the same length. And I'm also going to tell you, and I'm going to try and squeak it in here. I might make it bigger just so I can get it in. I'm going to tell you that this angle is 33 degrees. So then my question would be is, can you guys tell me the following? Can you tell me number one? What is that angle? Could you also tell me what is this angle? So that's y, and let's say this is x. So now I'm asking you to solve a couple of things with this information. I'm turning around and asking you to tell me what is x and what is y. So we need to kind of use some of our circle ideas to solve questions like this. So I'm going to draw a picture of a triangle. This is a bigger picture of that internal triangle. It's supposed to be the same as the one that I have in that picture. I'm just trying to make it a little bit neater. So when you look at this, a couple of things you guys need to know. Number one, this was X. We don't know what it is. We have a line running down here. We called this Y. We don't know what that is. We do know that this is 33 degrees. And we know that these line lengths are the same length. That's what we know about these triangles. So what I want you to look at and understand is, first off, I'll go back to my purple here to try to work this in. I need you guys to recognize when you look at this line and you look at this line that you recognize something unique. If this is the center of my circle, this is a radius, which means this is also a radius, which is telling us that these two line lengths are exactly the same. So if I'm looking at this big picture, if I'm looking at this as a big picture, these lines are the same. This is an isosceles triangle. And that means, we talked about it earlier, that this angle and this angle have to be the same. They have to be the same. So it told me here that that's 33. So that means X has to be, it's a horrible X. That means that X, I don't think I'm going to be able to do a funny X like that. I might have to do a normal X. That means that X is going to be equal to 33 degrees. And I got that simply using my triangle mentality. Now to figure out Y, if I know X is 33, I have to figure out Y. Well, a couple of things that, again, I'm looking at here. These line lengths are exactly the same length. They're cut in half. So that tells me that I can put a 90-degree mark right there. So now I know X is 33 degrees. I know that angle is 90 degrees. And Y is connected to those three. And therefore, I know that these guys need to add up to 180. So I can turn around and actually say, well, Y is going to equal 180, take away my 90 degrees, and take away that 33 degrees from my X. So I can turn around and actually solve this and have an answer. 180 minus 90 is 90. 90 minus 33, well, I'm going to go 90 minus 30 is 60, and take 3 more away. And I'm going to get 57 degrees. So I can say Y is equal to 57 degrees. So it's an important idea in terms of recognizing, number one, the idea that triangles you need to look at what you know about triangles, equilateral triangles, isosceles triangles. We need to look and understand what these lines mean. That means that equal side length. That means that we're creating a perpendicular bisector. And that means also then that we can use our rules about triangles and angles adding up to 180 degrees to solve this. So I know it sounds confusing, but we really need to work with these ideas that essentially we've kind of talked about here. If it passes through the middle and is 90 degrees to the chord, we say it's a perpendicular bisector, and a bisector simply means we've created equal. The side lengths of each of the sides are equal. We also need to recognize that if we have a perpendicular bisector, or the equal sides, that it makes a 90-degree angle. So those are kind of our key ideas in the start of this unit. We'll talk a little bit more about chords and distances next lesson.